This example comes out section 1.6, infinite sequences. In this question I'm asked, what's the limit as n approaches infinity of this rational expression here, 2n squared minus n plus 3 divided by 5n squared plus 3n minus 7. Looks more complicated actually than it needs to be. In the previous example, we saw that the limit as n goes to infinity of any 1 over n to the r is 0, as long as r is a positive number. So a tool that I use here that is useful for this type of limit is, let's divide everything by the highest degree of n. In other words, divide every single term here by n squared. So I've got 2n squared over n squared minus n over n squared plus 3 over n squared divided by, same idea on the bottom, 5n squared over n squared plus 3n over n squared minus 7 over n squared. That seems kind of weird. And as I go to the next level here, I've got the limit as n goes to infinity of 2 minus 1 over n plus 3 over n squared divided by 5 plus 3 over n minus 7 over n squared. And all of those approach 0 as n gets really, really big, except for the 2 over 5. So basically you have 2 minus 0 plus 0 over 5 plus 0 minus 0 equals 2/5. So there are other ways of thinking of that one, but that's one way of approaching that one. So let's try one more along the same line. Right, this limit, the limit as x goes to infinity of 5 minus 3x cubed plus x squared divided by 7x cubed plus x plus 4. If I use the same strategy and say, well, what's my highest degree of x? It's x cubed. So if I divide every term here by x cubed, I end up with something that looks like this in the first step, and lots of x cubes. It takes a second to write it, but at least I'm showing my thinking when I go to the next stage and say, okay, the limit as x goes to infinity of 5 over x cubed minus 3 plus 1 over x divided by 7 plus 1 over x squared plus 4 over x squared. And all of these that have a denominator of x squared, or x cubed are all approaching 0, so you end up with an answer of negative 3 over 7, which turns out that they're the coefficients of the terms with the highest degree. And this system works, or this method works, whenever you have the same degree on the top as you have on the bottom. The next part of this example here, slightly different format kind of setup of these limits. I've got limit as n goes to infinity of negative 1 to the n. If I start listing terms of this sequence, I've got negative 1, positive 1, negative 1, positive 1, negative 1, positive 1, dot, dot, dot. If I were to look at that graphically, it goes from negative to positive to negative to positive to negative to positive to negative to positive. It doesn't get closer and closer to anything, so this limit does not exist. You can't state that this limit is approaching anything, as it just oscillates, bounces back between negative 1 and positive 1 without getting closer and closer to anything. The next one, limit as n goes to infinity of 3 to the n. If I list the numbers, I've got 3, 9, 27, 81, etc. They just increase without bound. You could graph it, but it's just exponential growth, and so again, you just say it does not exist. Some people will actually say infinity. It's a bit more descriptive, I suppose, than does not exist, but definitely you can't state a real number answer to this. Now the next one, same format, except the base here is a half. If you looked at the terms, you'd have a half, a quarter, an eighth, a 16th. And if you did look at these graphically, they're getting smaller, smaller, and in fact they're getting closer and closer to 0. And it turns out that this one does have an answer that is 0. And then the next one, even though they are going to go negative, positive, I've got negative 3 over 7, positive 9 over 49, negative 27 over 343. And they are bouncing positive, negative, but they are actually getting closer and closer to 0 from both sides. And so, looking at them, they would eventually it's so close to 0 that you'd have 0.000000 something, and so this limit does actually exist. It turns out, in general, we can state a little rule here that says if you have the limit as n goes to infinity of r to the n, the only way that that limit exists, the only way that you can come up with an answer to that, besides does not exist or infinity or negative infinity type answers, is if it's 0, if that base is between 1 and negative 1. So if the r here is between negative 1 and positive 1, you have basically a fraction or a decimal, and as you raise it to higher and higher and higher powers, you're going to get answers closer and closer to 0.